Okay, this problem is asking us to draw. We need to draw out the shape of this to answer this entire problem. So we need to do a little bit of accounting first. So we're dealing with SO32 negative. So S has, we look at it, how many electrons does it have, or valence electrons does it have? It has the same as oxygen, so it's got 6. And then the oxygen, there's 3 of them, and they each have 6. And then the 2 negative means that I'm adding 2 electrons to it. So that's going to be my final total of 26 total electrons in my final thing. I'm going to put the sulfur in the middle because there's less of them. Normally we would say which one needs more electrons. Well, they all do here. So we're going to just put S in the middle. We're going to start by drawing some electrons around it. 1, 2, 3, 4, 5, 6. And then we've got an oxygen here. 1, 2, 3, 4, 5, 6. Oxygen 1, 2, 3, 4, 5, 6. And then, oops, let's move that one around. And then O, 1, 2, 3, 4, 5, 6. So this is going to have what is called a dative bond, which means that in most of my instances here, I'm going to be able to share some of my electrons, but in some of my instances, I'm going to have to unequally share my electrons. So, and I've got my overall 2 negative charge. So I've got 2 more electrons here than are originally drawn in. So one dative bond comes from these 2 electrons there. They're going to be shared between the sulfur and the oxygen, and so we could sometimes draw it with a little arrow to represent that it's a dative bond, but we don't need to. We'll just draw a single bond between it. My extra electrons, I'm going to put 1 on this oxygen and 1 on this oxygen so that I can clearly see that this electron and that electron would get shared between the sulfur and the oxygen, and then this electron and that electron would get shared evenly between those 2 species as well. And so I see here 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I met my total. Each of them feel 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. And it's all due to this extra 2 electrons that got added in there and a beautiful dative bond. So we look at the different possible answers for us here. We are looking at number of electron domains, or electron clouds is another word for that. So domains is the same thing as clouds around the sulfur. So here's my sulfur. Around it I have 1, 2, 3, 4 electron clouds. So C or D are going to be my answer. I can rule out A and B right away. The electron domain geometry, that is how this would be with the number of electron clouds total. So that would be tetrahedral, not trigonal pyramid. So we can cross off C, but let's do a double check, make sure that the rest of my answer here is correct. So when in this tetrahedral shape, 3 of them are bonds and 1 of them is an unbonded pair, that means that I've got a trigonal pyramid shape, so that is accurate as well. And the angle would be likely right around 107. So normally we have a tetrahedral being like 109, but since this extra unbonded electron pair is going to take up more space than the bonds do, it's going to shove those electron clouds or those electron domains around further. It's going to decrease that angle between them, and so 107 is perfect. D is the correct answer.